What does the future hold for aviation fuel? Will the skies of tomorrow be cleaner, greener, and more sustainable? These are the questions that have been buzzing in the minds of many as we look towards a more sustainable future. One potential game changer that's been gaining traction is hydrogen. Yes, the very same element that's the most abundant in the universe could very well be the fuel that powers our flights in the future. Hydrogen promises several advantages like zero carbon emissions during combustion and a high energy content, making it a potentially efficient and powerful fuel. But it's not without its challenges. Establishing a hydrogen supply infrastructure at airports, creating a distribution network, and addressing storage and handling issues are just a few of the hurdles we would need to overcome. So, let's dive into the world of hydrogen fuel and its potential role in the future of aviation. Imagine a jet engine that burns hydrogen instead of traditional jet fuel. The way it works is quite simple. Hydrogen is burned directly in gas turbine engines, very similar to how traditional jet fuel is used. The combustion process produces only water vapor and heat, nothing more. This means zero carbon emissions, a vital step towards reducing the aviation industry's environmental impact. Now let's talk about the energy content. Hydrogen packs a punch, making it a potentially efficient and powerful fuel. However, like any potential game changer, it comes with its own set of challenges. Establishing a hydrogen supply infrastructure at airports and creating a distribution network is no small feat. Moreover, hydrogen's low energy density by volume demands larger storage tanks and poses unique handling and leakage concerns. So while hydrogen could potentially revolutionize jet engines, it's not without its challenges. But isn't that the case with all great innovations? Beyond burning hydrogen, there's another way it could power our planes: through hydrogen fuel cells. These marvels of technology generate electricity through an electrochemical reaction between hydrogen and oxygen, driving the electric motors that propel the aircraft forward. Imagine the only byproduct of this process is water vapor, making it a true zero-emission solution. Furthermore, fuel cells can be highly efficient, converting a large portion of the hydrogen's energy directly into electricity. However, just like any revolutionary technology, it comes with its own set of hurdles. To begin with, we would need to overcome significant infrastructure challenges for hydrogen production and distribution. Additionally, the weight and volume of hydrogen fuel cells and storage systems could be substantial, impacting the aircraft's overall weight and design. Despite these potential drawbacks, the promise of a cleaner, more efficient fuel source is tantalizing. Hydrogen fuel cells could be a game changer, but there's still a long way to go. What if we could gradually introduce hydrogen into our fuel supply? This is where the concept of hydrogen as a blending agent comes into play. It means we can mix hydrogen with traditional aviation fuels, creating a lower carbon alternative. The beauty of this approach lies in its gradual transition. Instead of a drastic switch, we can utilize the existing infrastructure, slowly increasing the hydrogen content as technology and infrastructure evolve. However, this approach isn't without its limitations. The reduction in carbon emissions might be more limited compared to using hydrogen directly or through fuel cells. Furthermore, blending with conventional fuels means we're still partly dependent on fossil fuels, which isn't ideal for our long-term goal of a carbon-neutral aviation industry. So, while it's not the perfect solution, blending hydrogen into our fuel supply could serve as a stepping stone, easing the path towards a greener aviation industry. The road to a hydrogen-powered aviation industry is filled with challenges and considerations. First and foremost, we have infrastructure development. Establishing a hydrogen supply chain at airports and creating a distribution network would be a significant challenge. Then, there's the need for advancements in technology. We need more efficient storage methods, safety measures, and materials for hydrogen fuel. Economic viability is another major hurdle. The cost of producing hydrogen and developing the necessary technologies must be competitive with traditional aviation fuels. This brings us to the regulatory framework. Implementing safety standards and regulations for hydrogen use in aviation is a crucial step towards adoption. Finally, weight and space constraints pose a significant challenge. Hydrogen storage systems must be lightweight and space efficient to comply with the strict weight limitations imposed on aircraft. Hydrogen holds promise for a greener aviation future, but it will take significant advancements and efforts to make this dream a reality.